Hi everyone and welcome back to the channel. Today I'm out in the field testing this Bluetooth to LoRa gateway that we can use to send distress messages in emergency situation without using any of the standard communication technologies. The main purpose of the gateway is to provide communication in situations where there were a recent fire, like in this area right here, or the standard communication protocols are not in place because of some natural disaster. Stick around to see how I build this and how you can build your own. What makes this project special and possible is this module that I've recently got from my friends at Reyax. As you probably know, I've been working with Reyax for quite some time now, and many of my previous videos regarding LoRa and Bluetooth modules are actually with Reyax modules, and this is no different. So they sent this one out for me to test, and it's a special little module because it combines both BLE and LoRa into one package. The module itself is very small and compact, and it features these connectors for an antenna that can be mounted on the enclosure. The pins are broken up. Here we have power, so +5 and ground. We have a reset pin, and then we have the two interfaces for UART to communicate with both the Bluetooth module as well as the LoRa module. And we can easily place this into an enclosure. If we take a closer look at the datasheet, we can see that we have an image of the module as well as its features. So it has a 20 dBm BLE output as well as a 30 dBm output for the LoRa. It can be easily controlled with 80 commands, which is similar to how all of the Reyax modules work. And there's a special function that BLE can actually be converted into a long-range LoRa, and this is what we're gonna see today. And additionally, its firmware can be updated using the BLE OTA function, but we won't look into that today. What I'm particularly interested in and want to show you is how you can use this module to connect to a mobile phone and send messages through LoRa from your mobile phone that are then received to another receiver. If we take a look at the pinout, so pin 1 is where we have the BLE antenna on the side, and ground is on the LoRa side. Next one, D2, is the reset pin, and then we have takes for the BLE module and RX for the LoRa. Now keep in mind that those are one next to the other, and this is important in how we're gonna use it. And then we have D5 and D6, which are the takes, and RX for the LoRa and the BLE. In the specification, we can see that the power voltage is at 5 volts, but all the communication that we do is at 3.3 volts, so we need to keep that in mind. We can see all the other values, and most importantly, this can work on 868 as well as 915 megahertz, so it's compatible both in US and in Europe, where I'm based. I'm gonna use it on 868 megahertz. To communicate with the module on the computer, we need to use a USB to serial adapter that we can connect on one side to the computer. In this case, I'm using the one from Reyax, the RYLS999. This one provides output for 5, 3.3 and 1.8 volts, which not a lot of modules do. And I have it connected to the BLE interface. So as you can see here, the ones on the outside are the takes and RX pins of the BLE interface, and I have it connected appropriately to the takes and RX pins on the USB to serial module. And being connected like this, we can use one of the programs that the Reyax provides, which is Comfort, that we can use to communicate over UART, and you can download it for free. I have it here, and this is how the app looks. We can select the COM port that we have our adapter connected to, the appropriate baud rate, and we can choose to connect, and we can at this time initiate sending 80 commands, but I've created some sample scripts file that we can load. So the one for the BLE, we can run this command to query the module to get the name that is being set. And this is something that I already set previously, but if we modify it here, we can then choose to execute this command, and then the module will respond with OK, and it's ready. If we query the name again, we can see that it's now being updated. I'm gonna return it to how I had it set before. Now let's connect to the LoRa interface. For the LoRa module, the connection is exact on the level shifter, but we use the different pins on the modules. And keep in mind that you need to always switch between TX and RX. So TX on the module connects to RX on the board and vice versa. And if we now connect to UART and load the other script file, then we can issue the general communication command, so just AT. So and we should get an OK response, so we know that we are in communication with the module. There are several things that we need to do beforehand. So first thing is to check the address. This one is set to 2. And I've already went in and pre-configured the module, so I've already done this, but I will share the scripts and the process down in the video description if you want to follow along. Then we need to set the network ID. With the address, each module needs to have its own unique address, but they need to be on the same network ID and on the same band. Here, for me, the band is 868 megahertz, and this is what I had, but if this is something that's different, the module comes by default with 915 megahertz, so you need to issue this command to change it. And here are the other parameters like the baud rate, the spreading factor, and everything that I've left just with the defaults for this demo. So now that we know that we have the right address and network ID on both modules, we can go in and send commands to talk between each other. And here I've used 2 USB to serial adapter to connect to both of the modules that I have. So they both have LoRa and BLE. And if we go to the computer, we've now connected to the UART on both modules. And we can, for example, check the address on this one. That should give us address 1. And on this one, if we check it, it should be address 2. So we know that they are set correctly, and we can then use this special command to send data between each other. So I'm sending 5 bytes on address 2, and then received from 1 5 bytes with hello, and vice versa. I can send to address 1 2 bytes, and we have the 2 bytes received here. And this is the basis that we have for our messenger application that we're going to show. And just like that, with the microcontroller, we can easily talk on those UART interfaces and interact between each other. But what the Reyax engineers did on the module is quite clever and interesting, because we can use the module without using any additional microcontroller because of how the pins are being laid out here on the board. We can use a jumper like this. You might remember this from the era of hard drives. We can simply jump over the pins. So we are currently jumping over the TX and RX on the BLE and LoRa, and vice versa, the RX and TX the other way around. This way the module can receive any data on Bluetooth, so via BLE, and it's gonna transmit that data to LoRa, and the other way around. When it receives data on LoRa, it will transmit it to BLE, and this is what we're gonna use for our messenger. Okay, so now for the purposes of this demo, I have my phone and my son's phone, and I'm powering the 2 modules from 5 volts from my bench power supply. These are, both of them are linked, the 2 interfaces are linked together with the jumpers, and so there is no microcontroller in between. And this is a simple application that I created based on one of the examples that I've previously used for the relay control. You're gonna have that video up here if you want to check it in. Okay, so we can now start scanning, and let's see. So we see both of the device. Let's scan here as well as some other. So we have def 1 and def 2. One of the modules over here is def 1, and this one here is def 2. I'm going to connect one of the phones to def 1, and this is going to have address 1, so we'll have to switch to send to address 2. And this one will connect to def 2, and we're sending to address 1. So now when we start and enter an address, choose to send, the message should go through LoRa. And the problem with this demo is that because they're just too close to each other, sometimes that doesn't work on all of the tries. So you see, I had to send twice and I only received it here once. Hi from 2. Again. Yeah, so we got it. I'm hoping that once we have the devices further apart, test, we got it. So test other, no. We can have that message in both ways, and to do the proper test we need to build some sort of enclosures for the modules and mount the antennas on it. Okay, so here are the two communicating devices. Of course, nothing is really ready until we've rendered it. So let's add the necessary stickers and we can go and test each out. Okay, so let's test this one, and I'm gonna test one by one so I can identify which one is which. And I have the app here. So this one is def2 because that's the one being turned on. I'm gonna remove it. Let's start again. Yep, so we're not seeing it. Okay, let's turn on the other one. Okay, I'm not seeing that one. Let's double check the connections. Okay, so I've probably accidentally removed this wire. Let's solder it again. Okay, so let's try again. And here we have it. So now it's active and we can connect it to send to the other, but this one is not connected right now. Let's move them apart and try something out. And here's the final test that I'm doing here on my bench before I head out. I have the application here not connected to any device. This is device 1, and I have device 2 downstairs in the living room where my son is connected to it with his phone with the same app. And we're gonna try to verify that the communication works. So I'm gonna connect to def1. I need to connect to number 2. So let's try it out. I'm gonna say hi. His instructions is to check the phone, and whenever he sees a message from me, he should reply with something appropriate or whatever strings he sees. So there we got hi. I'm gonna send 1 2 3 4 5 6. Let's see what we get back. Now keep in mind this is the full communication, so I'm connected with Bluetooth. This is transferred through LoRa, so he replied with 789. I'm gonna say 987. Let's see what he replies with. And the message is transmitted to LoRa, to his device. I have selected 2 as the target. And on his device, he's connected to device 2. And he's sending to device 1, which is this one. So obviously it all works. Now I'm gonna go out on my usual locations where I tested some of the previous devices, some of the previous modules, just so that we verify that we can have a long-range communication. Here's the station out on my balcony, and I'm gonna head out in that direction towards that power plant. Okay, so here we are at location number 1, close to a shopping mall that's about 800 meters away, and we have the gateway inside the car. I'm gonna send, but you can see that we already received a message. Let's try and send something. Okay, we got the AAA, so I'm gonna send BBB just as example that we do have the communication. And as I said, this is about 800 meters away, and let's go to the next location. Okay, here I am at location number 2, and this time I'm way further down. I think it's about 8 kilometers from where that station is, up on that hill. I'm inside the car, and here's the gateway here on the dashboard within the car, and as you can see, I'm already receiving messages. So I'm gonna send just some test data, and we're gonna be receiving the reply back from my son, who is back at home. So yeah, we got something long. Let's send something long as well and see what he gonna reply with. But keep in mind that this is now way further down the road from. I've used this location once before when I was testing the RYLR999 modules, and I think it's something about 8 kilometers. I'm gonna have the correct distance down there, and let's see if we're gonna receive something else. Yeah, so we got some reply back, which means that the module is able to transmit to at least this distance. Now, I'm quite close to the power plant that I mentioned before, that you see from my balcony. Next stop will be to go past beyond it, and that would be something like 12 or 13 kilometers. I'm not sure. I'm gonna report from there. And also, I'm using the system to coordinate with my son, who is back home, so that I'm telling him I'm going further, and I'm gonna write once I'm there. So this works for actual communication. Okay, so our last location for today, because we are running out of light and we are way past the power station there, and this is the actual mine where they're digging up the coal. And as you can see, I've already sent messages, and this is gonna be tricky to film, but hopefully we get the message soon. The gateway is down on the ground, and yep, so we got something back from my son, who is about, I'm guessing, 13-14 kilometers at the moment in that direction over at that hill. So we do have visibility, but the gateway is down on the ground, and we're still able to communicate and send messages. For the Android application, I used my example that I had from the previous time we've tested one of the Reyax BLE modules, and here we have the characteristics for writing on the BLE as well as the characteristic for the notifications when we are reading. And there are basically just two functions that we need to know of, and the first one is the send message, the one that happens when you click on the send button, where whatever we've entered to the text box will be appended to the actual AT send command that we need to send to the LoRa module. And since this is relayed through the BLE module, it's gonna be sent to the LoRa module and sent to the target address with the message length and the actual message. And when we receive we have this parsing function where we are just removing the part from the beginning and actually extracting just the message that we have from the actual string that we've got. Everything else is just a support, so we are enabling notifications and just setting up the UI and some background logging for what's happening. I'm gonna have the entire code available linked below in the video description, so you can check it out and test it out for yourself. However, keep in mind that this is by no means a complete production ready product. It's just a proof of concept so we can test the modules. And with that, I'm gonna end the video right here. I hope you had fun watching it as I had fun building these two little devices. Even though they are relatively simple and don't require any microcontroller, they allowed us to communicate through LoRa on large distances. And I'm sure that if there's interest, we can possibly upgrade the whole system to be something like the mesh testing system that we have, which this one is greatly inspired by, but it's nowhere near the features that it has. If you want to see me do more projects with LoRa in the future, then be sure to subscribe. If you want to support my work, there's a link to my Patreon account where you can support my projects, because everything takes time and money and resources to produce these videos. YouTube thinks that you're gonna like this video up here, and I'm gonna see you all in the next one. Cheers!